So I'm not really sure what's going on here. I'm logged into the PC. It's not projecting. I'm logged into the into my laptop. It's not projecting. So not really sure what's going on with that. So we'll start out with a few administrative notes before we get into the content of the lecture. So first off, you had your second exam. I've had some students who have had issues with both the first and the second exam, and I think what we'll end up doing is that I'm going to I mentioned this on Discord. Did people catch that or no? Yeah. So here's the idea I'm having. I could do an optional third exam and then make the exams best 2 out of 3. If we did so, the only real time that we would have to hold the exam would be on the last Thursday of the semester. So basically you'd be getting this optional third exam and the final kind of back to back, right? Makes sense, there's not enough time otherwise. And it would be here in lecture. So less time, but I mean, I'd adjust the exam I'd adjust the exam to make up for that. Make sense? It's not, it can't hurt you, right? Because it's best 2 out of 3. So if you've already done okay on your first 2 exams, you can't do any worse. Okay, you can't do any worse unless, of course, you somehow cheat, in which case I guess you could do worse. So don't do that. Yes.
Content of the third exam compared to the final?
It'll probably be the exact same stuff as the final, with probably a bit of an emphasis more on the stuff I'll start covering today, which is regular expressions, which usually is an optional portion of the course. Now, for those of you who are unaware, and because I haven't mentioned, because I've only briefly mentioned this a few times, the way that my final exam has worked for the past couple semesters is that I've been a bit lazy. And the students have really liked that. And it works very well as kind of figuring out which students are able to code and which cannot. And it works like this. I will give you some so I have done, one semester was basically, here's 5 questions, each worth 20 points. Another semester was, here's 7 questions, choose 5 of them. This semester I might do something of, and another semester was, here's a bunch of 5-point questions you have to answer, and then here's here's another one where basically it's choose 4 out of 6. Make sense? So generally speaking, there will be stuff to choose from if you're not feeling as confident in that area. Make sense? I like this idea of giving students choice. In the past, it's always been, let's see, the topics for a final have been, let's go over a list of lists, turtle question, so probably be something along the lines of, here's a turtle program, draw it. Another one, there's always a Monte Carlo problem. There's always a file reading question. I think I mentioned list of lists already. There's always a regular expression question. I have a list I came up with, and I'll be able to reference it, and I'll tell you what those are later. And of course, I have more practice questions for you because I've given out a lot of exams, and I turn questions I like from old exams into practice questions. Previously, Monte Carlo questions have covered the range of the gamut from a Dungeons and Dragons attack roll simulator to simulating a child's board game. Literally, the rules are designed for toddlers. That one in particular, I gave over COVID, and is the reason and it accounts for more than half of the academic integrity violations that I've had to submit, because I gave that over COVID, and a lot of the students didn't realize that. First off, I hate the software that you had to use during the COVID to lock down the browser. A lot of those were easy to defeat. A lot of those I felt were too good at giving false positives, and it just felt adversarial. So I just simply gave a question that I knew was on Chegg. And not only did I know it was on Chegg, I knew the answer on Chegg. And let me just those of you who have been in this class will know why these are markers, but simply put, I saw a bunch of answers during COVID that have the same markers as in the text, where you would have the if statements and the while statements with open parentheses, close parentheses around the clauses, which is a thing in other programming languages, but not necessarily a thing in Python, right? So it would be if open parenthesis, da 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 da, close parenthesis. Also, there was spaces right before the close parentheses, which is an unusual syntactical marker. So it was very easy to kind of prove that these were all very similar. Plus, they would have the same structure, do everything in the same order, maybe change around the variable names for good measure. It was. So, long story short, pattern recognition is a subdomain of computer science. We'll be talking a bit about pattern recognition today when we talk about regular expressions, but I can still use that question and have over many semesters because it's a damn good question. The rules are literally a toddler's board game. It works. Let's see. So the exam 3 will probably cover much of the same topic. I'll have to get to work on crafting it. But that's not something you have to worry about yet. That's not going to be a thing until December, because that's when classes end, right? So we'll do it in lecture during the last day of class. Okay? And again, it will be completely optional. Hi there. I didn't break it, I swear. All right, so I'm going to go ahead and pause this while I try to diagnose this. Okay, so while that's going on, so that should at least address like students asking about extra credit opportunities on exams, as well as the 1 or 2 students who somehow managed to miss the exam, which may sound like I'm shaming you for pointing out that you may have missed the exam either for forgetting about it or oversleeping, but I totally did that as an undergrad. I missed one of my Calculus 3 exams by just sleeping through it because I was terrible at college for the first 2 semesters. Sorry, first 2 semesters? I mean first 2 years. I was terrible as a student for those semesters. So if that happens, I guess own it and come to me. All right. So today's lecture is going to be a bit of an eclectic mix. I had an entire bit planned where I was going to say, hey, we're going to talk about something nice and not stressful. Anyway, hey there. Hi, I think somebody's already going back and checking the projector stuff. Yep. It's not my fault for running Linux this time. Usually that's the reason, but not this time. All right, so to start out with, let's get into the content of the lecture. Who knows what Florida Man is? Yes?
You want me to explain?
Yes, please explain for the class, because a lot of the class, believe it or not, is international and does not, in fact, necessarily know what Florida Man is or why that's a thing.
Florida Man is a joke that comes from the amount of headlines that have a weird ending but start with Florida Man.
Exactly.
For example, Florida Man brings crocodile to drive-thru.
Yes, or wrestles alligator, right?
Usually has to do with
It usually has to do with gators. Florida is special, like that. Let's say it's a wonderful place, and it has an eclectic, and because it's just got such an interesting climate. Okay, great. We see that the PC is going. Let's go ahead and hit the laptop. Let's see. Can we get to the laptop? Let's see. All right. So one of the jokes for the Florida Man meme is you can simply type in Florida Man and your birthday and see what weird story pops up. For those international students, Florida is that peninsula state on the southeast of the United States coastline. Awesome. Let's go ahead and project that. It is home to wonderful things, and also just generally a lot of crazy stories, and it leads people to believe that Florida in itself is crazy. This is not necessarily the case. Floating projector, there we go. Sorry, give me 1 second. I need to screen. Let's see. How do I? Yeah, close that. Close that, and then full screen projector preview on there, and that should work. Excellent. Okay. So, right. Now I meant to pull these things up earlier, but we can just look at Florida Man, right? So, right, Florida man meme, Florida man convicted at shooting at ATF. Florida man gets 22 years. Florida man reportedly stabbed his brother for taking his food. Florida man electrocuted in Yabusha County. Florida man and notice that they all start with Florida man, okay? Now, why? Is it because there's an unusual number of crazy people that live in Florida? Why am I talking about this anyway? What does this have to do with computer science? Part of it is, of course, being amusing. But does anybody know the reason why the Florida man meme is a thing? Anyone? Yes?
Search engine optimization?
Search engine optimization, maybe, maybe not. But it actually has a pretty good reason for it. Let's go to Wikipedia for a second. Because for Florida man, the idea of Florida man is somehow the idea that Florida is somehow more eclectic and eccentric than the rest of the United States is, and anybody who's lived anywhere in the United States knows that every single different United States has its own kind of special weird thing, right? That makes it itself, and it's wonderful. But the reason behind Florida Man actually has a pretty good reason. The Miami New Times, which I guess would be a bit of a biased source in this case, states that it's because of the Freedom of Information laws in Florida. Florida has what are called sunshine laws, as they are. Simply put, a lot of things are public record in Florida. A lot of things. Meaning that it's very easy for a journalist to go in and grab the details of police reports. Much easier than in other states. So you can find these weird crime arrests about a Florida man who was bringing his alligator through a drive-through, and that's just simply easier to find, right? Add in the fact that you've got a very large population in Florida, right? Plus you get a number of tourists there, and suddenly you have plenty of things to write about, okay? So the sunshine laws, and there is quite a bit of a thing. Florida is one of those states that really kind of led the way in making sure that, or leads the way in making sure that information is open in there. One of the things, and so this brings us to the actual topic of our discussion for today, which is the 2016 Republican primary for the United States president. Yes, we're talking about elections today. Now, I need to preface this by saying that I give this lecture every single year, and I speak about this particular individual because this is the most recent individual who does this. The next time we get a individual who, on either side of the party, who does this, then I'll be talking about them. And it's not who you're thinking about, because it's another meme-tastic person, but not that meme-tastic person. No, I am talking about flawless victory man himself, Jeb Bush. Jeb Bush. For those of you who don't know the flawless victory meme, it is just something that gets posted around every single election. Doesn't matter what the election is, or if it's an election in another country, this is the meme that gets posted, which is just Jeb Bush in this stance, just celebrating, basically sweeping the entire states, because of course, but no. So for those of you who don't remember, Jeb Bush actually has had a long history in the United States. So let's go ahead and look him up. He is the brother of the former president, George George W. Bush. I always forget if it's H.W. or W sometimes, but it's George W. Bush, who was son of H.W. Bush. He was the 43rd governor of Florida. 43rd governor of Florida from these years, 1999 to 2007. Okay, so he had a quite long tenure as governor, and one of the things he was known for was basically being, as he put it, the e-governor. Because before we started putting in I in front of all the computer stuff, we put E in front of all the computer stuff for electronic, like email specifically. So if you note those years, that is kind of the years where the internet started getting adopted by people to be used for things, where you started getting websites and individuals started making websites. In fact, one of the things that Jeb Bush really enjoyed was the fact that he had he had to email, and people could email him about the kind of issues that they were having. And believe it or not, it's not just like kind of political issues that you need to email somebody like the governor about. For instance, one of my favorite examples is, what if you end up dead? Legally speaking, you were accidentally declared dead. Can't receive any social services. This happens, by the way, that you are accidentally declared dead. And yes, you're there in front of the government, in the DMV, trying to explain that you're alive, but the system says you're dead. You're obviously not alive, and this is above my pay grade. I can't handle this. You might be, running an elaborate fraud on me, or trying to, identify, try to appropriate the identity of this dead person. This happens. People have accidentally ended up declared as dead, just legally speaking. Maybe because you share your name with somebody else. It happens. Generally, the easiest way to get this resolved is to make noise and bang on state representatives, so at your state level, state senators at your state level, your federal representative, your senator, or your governor, because they're the people who can cut through that red tape for you. They're the people who can cut through the red tape for you. So yeah, that's the kind of stuff that happened. Now, the 2016 election was a while ago. I think it was like 8 decades ago at this point, right? It's been a long couple of years, politically speaking, because of the 24/7 news cycle. But so what happened is that Jeb Bush wanted to run on being an extremely transparent individual, and he used his emails as a kind of example of that, and he released all of his emails online as a big data dump so people could go through his 8 years of him being a governor and see, hey, this is the things, I've got nothing to hide. Very admirable thing. He just made one huge mistake. A Florida man-sized mistake, if you will. Florida man accidentally releases personal identifiable information online. That would be the headline there. Let's see. Jeb Bush email, I think it was The Verge that had the article that I typically, Jeb Bush dumps emails including Social Security numbers of Florida residents online. So again, context for those of you who are not U.S. citizens. Social Security, the United States does not have a federal ID system, right? You don't have a U.S. government ID. You have state IDs, right? You have a driver license that often serves as that, and you can have a passport, but the passport is optional, right? You only need that if you're going outside of the country. But there's no mandatory federal ID. The states require the ID, and they implement their own. I mean, there's about 50 separate systems. The U.S. has just been kind of very reticent about that. Yes?
Aren't they introducing that idea with the real ID system?
Yeah, kind of, sort of, and you can see how slow the rollout has been for that. I mean, you got to understand that for context, it took a long time before for the term to go from these United States to the United States. Right, the states themselves enjoy having a huge level of independency from the federal government. Believe it or not, I know it seems like it not the case sometimes, but you can see it when you look for it. So, as a result, though, you need some kind of ID number often to tie people to each other, and my Social Security card that I have says this card is not to be used for identification purposes. Eventually, I think they just gave up and stopped putting it on the card because now it is used as a ID card, as an ID number, which is just a terrible idea. Yes.
But isn't everybody's social security number public now? Because of a massive breach of the IRS?
Define public? I mean,
We're all technically pwned, basically.
I mean, yes, but no, but also yes, but no. I mean,
That's real, by the way.
I know. What is it? Not every U.S. citizen does have social security, have a social security number. A few separate religious groups have had a carve out when it was introduced. So, but again, we're getting into minutia here. For the long and short of it, social security numbers are generally things you want to keep private. And this accidentally got dumped on the internet. Now here's an example of some of the emails that we can see here. As to like, why would you email the governor that very important number, you know, that you should keep private? And you get things like this. So you see this. So here's an example of an email, redacted. Dear Governor Jeb Bush, RE, redacted name, social security number, blank. This letter is to inform you the facts regarding blank's employment with the House of Hope Orlando. Blank is a vital part of our boys program. The moral character and integrity of this man is not in question. As we dealt with blank, the following are documented. He's worked here. He has letters of accommodation, been a law-abiding citizen for 7 years with no legal charges, completed all the New York State stuff. New York State is where the charges occur, and New York State cleared him to work with children without concern. His current probation officer has no problems with him, and she's aware of his position at House of Hope. So here's another one for health care. I'm now in touch with Stephen Ulfelder in Tallahassee, representing Tenet Health, and Don Stigman to call Tenet Healthcare. So this is just an email saying this person needs surgery. Please help this kid, right? This kind of email. And as we can see here, there's the Social Security number and the health insurance number for this person. Okay. So this happens. This was not malicious by any means. People are just people, and they do people things like this all the time, where it's an accident, right? It just happens. So the question, though, is, what can we, as programmers, do to prevent this kind of thing? And the answer is that we can look for patterns to try to detect things like social security numbers and strip them from anything we try to release. We can sanitize these documents. Now, 8 years of emails, you cannot go through and read them all, right? That's going to be a real pain in the butt to do so if you want to try to get that on time. Ideally, that's what would happen, but that's not just the way people work, right? Okay? So what we do is that we could write a program to make this a lot easier for us. So this has been a question on my final before, once a long part of time ago. Write a program that, given a text file, strips all the social security numbers out of the file. That has been an actual question asked on the final exam. Other questions have included, here is a document that contains telephone numbers in it. Write a program that strips this file of all the telephone numbers and replaces them with redacted. Okay? Or write a telephone program that, write a program that basically removes email addresses from this one. So the question then becomes, how do you write, but let's go with social security numbers or phone numbers, okay? Phone numbers are a bit easier, and we can look at an example in one of the textbooks I have listed, but we've not really looked at. So this is automatetheboringstuff.com, automate the boring stuff, right? .com. And this is a free textbook, although you can buy it yourself. It's one of the things I've listed in the syllabus. And it's been a very good kind of just really good resource. And what we're looking at here is the chapter 7 in it, which is pattern matching with regular expressions. Now, this is what the lecture is actually about, regular expressions. Now, regular expressions, unfortunately, are weird in the sense that they're weird as to where they get introduced into computer science curriculum. which is that they don't, generally, unless you're taking one of the hardest courses in computer science, which is automata theory, which is a computational linguistics course, which has and it crosses with mathematics. Basically, the entire course says, what can we mathematically prove computers can do? Yes, you can mathematically prove computers can do one thing and not other things. It's very interesting. You prove things like the halting problem in computer science. Basically, can you tell if a program's going to run forever? Those things, so that's the class. And the thing is that regular expressions themselves are just way too freaking useful to languish in that senior level class. This is one of those things where even if you're not a computer science major, okay, if you are a non-computer science major, you spend 2 hours practicing this will save you days worth of work down the line, days upon days. Because you can do things like identify random strings that match a pattern. Every single programming language has a regular expression library built in, and all of them use the same syntax for it. So you learn this, you've got this available for you in every single programming language. It's available for you in Java, it's available for you probably in C, although you have to import the library. C++, almost certainly. Rust, definitely. Every single programming language has this that people use. All right, so those of you, hopefully most of you know about Control F at this point, right? You press Control F on a Word document or on your web page, and it brings up a thing over here, Find in Page at the bottom, where you can look for something like, I want to look for pattern, okay, and find things like this, okay? What regular expressions will do is it does this on a much more powerful level. They let you search, as it says, they allow you to specify a pattern of text to search for. For instance, you may not be able to search for a specific business number, but you can search for anything matching the number format for a telephone. Okay? Right? So if you live in the United States or Canada, you know that a telephone number is 3 digits followed by a hyphen, then you've got 4 more digits, and then optionally there's a 3-digit area code at the beginning, although now it's simply always a 3-digit area code at the beginning. So 3-digit area code, 3-digit number. By the way, 555 is the number that's always used, that is kind of reserved for movies and TV shows. For basically nothing is going to start with 555. So it's the fake number that gets used in any kind of television show if you need a number. That's it. These numbers can be anything. Anything. As long as it's 555, it's going to be not a real number. So that's why. And if you didn't know that, now you'll be able to see that in every single movie and TV show you watch, and you'll not be able to unsee it. Okay. We know that this is a telephone number. We know this is not. We also know other things it says. Email addresses have @ symbols. Social security numbers, as we'll see, have 9 digits and 2 hyphens. Website addresses have periods and forward slashes. Right? So, regular expressions are helpful, but few non-programmers even know about them, though most modern text editors and word processors, such as Microsoft Word or OpenOffice, have these built into them. Yes, you can use this in Excel. Yes, you can use this in Microsoft Word. Yes, you can use this in VS Code. If I go ahead and open up code, for instance over here, and I just simply hit, so here we go, release notes, whatever. I'm going to hit Control, I'm going to create a new document. No, actually, I'm right here. Control F, right over here. Or does it not let me do that over here? Come on. What about over here? Yes, it does, over here. If you're working in a program, it's hard to see here, but if you're working in VS Code or something like that, notice over here it's got little symbols over here. Match case. Match the whole word. And then it's got this dot star. And if we hover over that, it says, use regular expressions. This thing is everywhere if you look for it. It's very useful, very powerful. Okay, so now why? Why would we want to do this? So finding patterns of text without regular expressions. let's look at a Python program that would look for a telephone number that looks for a telephone number without using any regular expressions, right? Use a phone number called, we're going to use a function, is phone number, and it's just going to check for a string of text and says, hey, is this a telephone number? And you're going to say, hey, if it's not 12 things long, return false. Why? Because it's got to be 12 things, because a telephone number is, we're saying three numbers followed by a dash, another 3 numbers followed by a dash, and another 4 numbers. So 3 plus 3 is 6, plus 4 is 10, plus the 2 dashes, that's 12. That's how we get that. For each of the first 3 letters, if it's not a number, return false. Then check the third letter. If it's not a dash, return false. Then check 4 through 7. Make sure they're all numbers, otherwise false, and so on and so forth. So a fairly long program. And then here we go. So is this a telephone number? Print it yes. That'll print out true. Is Moshi Moshi a telephone number? No, it is not. However, what you'd have to do is that, now though, how would you use this to find a telephone number in a string of text? What you would have to do is you'd have to look at whatever text you have, such as this, and then you'd have to look at every 12-character chunk in the message. You'd have to look at this, so whatever 12 is, and then you'd just look starting here, and then you'd look starting here, and then you'd look starting here. There's ways to optimize it, and then you'd have to call that. And that's quite the complicated thing. So it would check call me at 4, all me at 41, me at 41, me at 415 dash, and so on and so forth. And so so also it's very limited here, though. We assume that every telephone number would be, 3 digits dash, 3 digits dash, 4 digits. But a lot of times we get something like open paren, 3 digits, close paren, space, 3 digits dash, 4 digits, right? I know that was all a lot, so let me type it out. A lot of times when we are getting, right, when we get this, we get, oh, cool, I zoomed it all the way in, see? There's your find. So a lot of times telephone numbers look like this. 123 space 555 dash 14234. They might look like this, and that looks completely different, right? Than what we had. Then 123 dash 555 dash 1234. It even has a different number of characters, right? Fortunately, you could write a fairly trivial regular expression to handle that. And it's extremely useful. Let's see. So let's see. So how do you do this? So we write regular expressions, or regex is for short. So the way you match a telephone number is like this. And let's go ahead and just simply go to another website called Regexer. Regex, so REG, and I'll just drop it in, and I'm going to just drop it on my screen nice and big for you. Right? We're going to go here. Regexer, so regex, regular expression, r.com. And you'll be able to play with regular expressions on this website. Okay? Let's go ahead and mute that. So here you go. Simply put, you put your regular expression in here, and then you have your tests over here, or the text you're checking on. So for instance, if I want to test on my telephone numbers like this, it can do so. So this might be that email that we're talking about, this mythical email that we're trying to sanitize, okay? And by the way, once we find these strings, it's fairly easy to go through them, okay? So what we're going to do over here is we are going to delete that. And first off, how do regexes work? First off, if you just want to use any letters to search for a word, it's not too hard. Like was, boom, done. It'll just work like that, just like in normal control. What matters though is that we can use symbols and special commands in here. For instance, we can use /W to represent something like any character that's a wordy character. In other words, something that's alphanumeric. Okay? Well, more relevant for us, if we want to say, I want to look for a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8, or a 9, or a 0, we use /D. Notice that all the numbers down here lit up. So this /D matches any digit character, 0 through 9. So if I want to look for a 3-digit number, it's very simple. I just do 3 of those to match a digit. And now notice that it's grabbed, it says, aha, found 1, 2, 3, I found 5, 5, 5, I found 1, 2, 3. It doesn't grab that because it's not part of it, right? So it's greedy. So it just simply grabs that first match that it can, and then it continues from there. So that's why it doesn't highlight 1, 2, 3, 4. It doesn't grab 1, 2, 3, and it doesn't grab 1, 2, 3 as well as 2, 3, 4. It just simply grabs the 1, 2, 3 and continues on from the 4. Okay? Because that makes sense. It does. So if I want to find a telephone number, it works like this. /3/Ds for 3 digits, then as a hyphen on equal sign, and then another 3 digits, and then another 4 digits. Similarly, if I wanted to look for a social security number, social security numbers work like this, by the way. They are 3 digits, followed by 2 digits, followed by 4 digits, 4, 5, 6, 7, 8, 9. They look like that, which, as you can see, is different than a telephone number, right? It's fairly easy to write the regular expression that matches that. It is /D/D/D, so 3 digits followed by 2 digits followed by 4 digits for a social security number. And that's it. That's really all you need to do. And then once you have that, it's about 8 lines of Python in total to do file input output to basically strip a file. That is something I'll be going over on Thursday, by the way. The whole how do we use this in Python. Today I'm just going to focus on the syntax of this. On Thursday I plan on going through an exercise that I normally give for extra credit, but I want to go over it in class because they make good questions here. So today we're just learning about regular expression syntax. Thursday we're going to learn more about how to use this. And you can also see why this is an optional part, right? Because this is not going to come up. Nobody's going to ask you in the next class or the class after that, hey, did you not learn regular expressions? No, I didn't learn regular expressions until I got to that automata class. And I think it's a darn crime that most students don't learn about this. Okay? But because it's not, so this is part of the reason why things are optional in the, why I mentioned that this is an optional part of the final exam. If you do take exam 3, though, I will be asking you questions about this, though. Again, if you missed that, I'll be giving out an exam 3. I think everybody's in favor of this idea of doing an exam 3 and take the best 2 out of 3 of your exam grades, right? And if you're happy, guess what? You get a day off. So, you know, and it's the day where you're finally, and it's that last day of classes, you're totally ready to not come into class. Okay, so that's how you can find this. Now, what about other things? Parentheses are used, as we'll see, for special things like doing groups. But specifically what we want to do, let's see, does it do it here? Nope. See, it doesn't, 1 second. So as you can see, even though we did something like this that doesn't match, it doesn't, so parentheses, it says something about caption groups. We'll get into those later. We don't have to worry about that. Just know that some things are special symbols. Specifically, things like the star character are a special symbol. The parentheses are a special symbol, and period is a special symbol. That's probably the most well-known of the special symbols of regular expressions. But for parentheses, how do we do those? We use escape characters, just like we do for other things in programming languages. So here, this says, I'd like this, followed by 3 digits, followed by this. And then, so we can make more complicated regular expressions that have ands and ors in them, but honestly, we don't really need to do that. Right now, I want to focus on kind of the rules and kind of explain what these regular expressions can do. Now, for those of you who are mildly interested in the mathematics of this, regular expressions are basically regular expressions are a implementation of they're derived from theoretical computer science and formal language theory. Specifically, it is, regular languages, right? The concept began in the 1950s when American mathematician Stephen Cole Kleene formalized the concept of using a regular language. Regular language is linguistical theory, and it talks about an empty language with null set is a regular language. For every character in the alphabet, sigma, A belongs to sigma. The singleton language A is a regular language. And then, so you can see it getting into mathematical theory here, which is boring stuff. But this is where it comes from. More importantly, where does that come from? A regular language satisfies the equivalent properties. The language is accepted by a non-deterministic finite automata or a deterministic finite automata. Which is a fancy way of saying regular expressions can capture something basically as powerful as a flowchart. Okay, that's what we're saying. Discrete deterministic finite automaton. So, brief computer science formal automata 101 here. You're not going to be tested on this, but just so you have the background. There's separate levels of kind of languages in computer science. You have deterministic finite automata on the bottom, essentially, or regular languages. So you have the regular language, and the machine equivalent of that is this deterministic finite automata. Okay? And it is just simply a state machine. It is a flowchart saying, okay, we are at this state, we can go here or here. An example of this is anytime you see doors that automatically open and close. They're in the closed state, they'll change to the open state once they see that something is in front of them. And when they're in the open state and something is no longer in front of them, they'll be in the closed state. It doesn't require any memory whatsoever on that. It's just simply going from one state to another state based on the conditions it can detect. Okay? You can get, the next level is context-free grammars. This is, and those use something called stack machines. And the next level about that, the linguistic side, the thing on the linguistical side is a Turing-complete language, and the thing on the machine side is called a Turing machine. In other words, a computer. And basically, so this is where it comes from. It's basically the building blocks of how we get to a computer using these deterministic finite automatas, and then building up through them to kind of show that these things are able to be built using kind of the proofs that we use below. So there you go. But we don't care about that. We can use that to basically match usernames or something like that, or find emails. What we cannot do, the limits of this, is actually testing to see if parentheses are properly nested. That's kind of the breakpoint of where a regular expression power ends, and you need something more powerful like a stack machine to deal with that, or context-free grammar. So let's talk about what kind of abilities that means we have. We have the ability to do wildcards, like this, GOA, and then we can do dot for the wildcard character, which means that this will match goat goal, let's see, goad, right? So it'll match all three of those four-letter words. GOA, wildcard character, right? It will also match, of course, Goa, because it's got an exclamation point, or Goa, or just Goa. It'll match all those because it's looking for anything. The dot means anything other than a line break, meaning end of line. Okay? Very useful, very kind of useful thing. Another useful thing you can do is we had this idea of /D over here to match anything that's a digit. And I briefly introduced you to /W. /W gets any letter and any digit, as well as one other character. Rosen, you can't even spell your own name? Come on, man. All right, so useful, as you can see here, for getting usernames, right? Basically, anything that could be properly inside of a variable. That's what W is. And then we have one final / character, which is super easy, /S for white space. And as you can see, it's just getting all the spaces over there. It can also grab tabs. It's happy about grabbing tabs, too. Now, it has also, we also have their inverses, which are super easy to remember. The inverses for these are super easy to remember. So /D over here, let's go look at /D again. Here are the numbers. Let's go back, scroll back down to them. Okay. There we go, there's our numbers. And if we do capital D, we get everything that's not a number, right? So that's pretty cool. Similarly, /W gets you any word character. Stay on page. And capital W gets you anything that's not a word character. So everything that's not a letter or a number or an underscore gets highlighted now. And then /S for white space, /S for everything that's not white space. Cool and useful. Okay, Professor Rosen, but what if these character classes don't match anything that I particularly need? What if I'm playing a game of Wordle and I've got a dictionary document, right? I've got dictionary diction. Here's a dictionary.txt file. Let's go and get dictionary.txt file, right? Cool. Right, can't show me, whatever. Okay, download this file. Okay, let's go ahead and open it up in VS Code. I think it will open up in VS Code. Let's see, no. Listen, let's go ahead and open it up in VS Code then, okay? Because we can see regular expressions in VS Code. So let's go to Downloads, Words Alpha. Yeah, I want to open it, I know. And here we go. Okay? So suppose you're playing Wordle, and you're like, and I've got this, and you're drawing a blank here. Okay? First off, we can look for any 5-letter words by just simply entering regular expression mode and going /W/W/W/W/W, and now notice that you've got these 5-letter words. I'll talk about how to remove these parts later, okay? Because we're highlighting stuff like aardvark, and I'd rather not get that. I want only 5-letter words, but we can handle that. Aardwolf is apparently a thing, okay? You learn something new every day, okay? So, what though if I know that I've got like a T and an R, okay? And I know that, and I just know, okay, just from inference, that these two characters over here have to be vowels, right? How do I look for something like that? And the answer is you can make your own character class. So I'm going to do it on regexer for a second before we go back to that, okay? You can make your own character classes, right? And the way you do that is using brackets. And brackets basically say one of the following. One of the following of the inside. So for instance, if I want to say, hey, I want to match I want this to look for anything that's a vowel. A, E, I, O, U. Like that. So that says match, I want you to match an A, an E, an I, an O, or a U. If I want to do something like this, this would say, hey, match everything that's a T followed by a vowel. Make sense? So matches favorite, the ta in details, the two in capture, the two in customs, and the T in patterns, right? So this allows me to basically specify, hey, I want to see whatever this is. Also, it's got some very nice syntax. For instance, you could do A, right, maybe you do A, you want to say, I want to like do some parts of the alphabet, A, B, C, D, E, F, G. Oh, gee, writing this out is so hard, I just want to match all the letters from A through K for some reason, okay? Believe it or not, it works like you'd hope it to. A-K for A through K. You can do that. You can also do that with capital letters as well, and just put them next to each other, yes.
Will this work for numbers?
That is a great question. I've never actually tried it with numbers. Let's go ahead and find out. Apparently not. Well, no, we don't have a T here, so let's find out. Yes, it works for numbers.
Okay.
Cool. So, going back to our example over here on how to find, if I want to find a T in followed by two vowels, TR followed by two vowels, I could do TR and then A-E-I-O-U, and then I could do that again. Whoops. A-E-I-O-U. Yes, there's a way to not have to repeat it, and I'll just get to that. And then finally what we'll do is we need another letter, just any letter. And let's go and figure out now, how in the world do we make sure that that we just have this? And I believe it is what? Beginning, can I do just boundaries like this? Yes, I can. So what do the slashes B's mean? It means boundaries. In other words, beginning and ends of lines. And now I can go through and just simply go through all the letters that start with T and R and have two vowels in the middle. And then any other character in the end. You can see where this comes useful, right? It's a very kind of powerful kind of tool you can use. Possibly to make sure that you don't accidentally dock somebody, or maybe you can use it to cheat at Wordle. I don't know. The power's yours. But what else can we do? So what else can we do with it? So as you can see over here, this is a bit unwieldy, the A-E-I-O-U repeated twice, right? What if you wanted to look for a word that had, a five-letter word that had three vowels in a row, right? I want to look for three vowels in a row. Do I really want to, or any word would have three vowels in a row, okay? Do I really want to have to write this out 3 times, A-E-I-O-U? That kind of gets really frustrating to have to do that. And the more times you type something out, the more times you have the ability to fail at doing something like that, right? The more times you have to type something, the more times you have to make typos. You can specify a numerator. Not the fractional numerator, but the number of times you want to do something. So, so you use curly braces and you can say, hey, I want to match anything that has 3 vowels in it. Find all the words that have 3 vowels in it. And we can go through. Now this numerator is actually fairly powerful. Curly brace, and then you put one number in to say, I want to match exactly this many. Is there any words that have 5 vowels in it? Apparently yes. Queuing, yes, definitely queuing. That one actually looks fairly well. So it's got a lot of, that is a lot of vowels, honestly. and Q's. So what about, we can also do something like this. Any word that has 3 to 5 vowels in it. So 3, 5, if we don't want an exact number. Right, if we want to leave it up to more stuff, I could say 5, blank, and I could leave it to any, and that says, hey, I want words that have at least 5 vowels in them. Make sense? I don't know if there's any that have 6 in them. Let's find out. Are there words that have? Yes, there are. Do we even want to know? Okay, that is the only word that has 6 vowels in it. I think that's it. We can't go above that. What is that? A musical mnemonic. A musical mnemonic. That's interesting. Okay. That's pretty cool. Okay, there it is. Securelum amen indicated with the abbreviation UWE. UWE? I wish I could read this. I don't know how to read the IPA, which is frustrating. So you can see that this is a fairly powerful kind of thing. Okay, so we went over numerators and and things like that. So numerator gets us to the final two symbols I need to talk about. These are the ones that actually typically get introduced first in automata theory, but are less useful for us humans because we aren't computers. Computers care about these ones a lot. So let's go with this one. Plus. A-E-I-O-U plus. That matches anything, that says find any sequence that has at least one vowel in it. At least one. The plus means at least one of the preceding. So here I could say any number of vowels followed by a T. Right? Any number of vowels followed by a T. Okay? So, Uriastic, and I bet you enthusiastic would probably be one of those as well. So this is very useful. You could just write 1 comma, sure, but this is also very useful. But this comes from now. This one's even more useful in computer science. Less useful here, but I'm remiss to not introduce it because we have this dot and we have this star here. So it's time for us to talk about what that star is, okay? Because the dot star is the symbol for regular expressions. So the dot means any wildcard character. The star is known as the clean star, named after that guy I just mentioned, K-L-E-E-N-E, clean. And, all right, so it matched this word, Urothoptera, which has no vowels in front of it, but it also matched Eurosmite, which don't know what that word is, but what does that star mean? It means at least 0, as opposed to at least 1 of. It means 0 or more. So it may not have a vowel, it might have a vowel in front of the T. That's fine. It's not too upset about this. Let's go with maybe 2 T's. Yeah. So any number of vowels in front of a T. These are now 2 T's. So etiquette. There we go. So any number of vowels, choose any number, followed by a T. Followed by 2 T's. Let's go and find. And you're always going to find 2 T's, by the way. In this case, just because of the way the English language works, you're not going to get 2 T's without a vowel, I don't think. No, you're not. You're just not going to. But it's a very powerful tool, and we use it a lot in these kind of things. So what kind of questions will I be asking in the future, in lectures, and what kind of stuff? In the next lecture, what I plan on doing is I plan on working on something I've given out as extra credit. I'm not going to give it out as extra credit this semester. We're just going to do it in class so that you all have exposure for this, so you can all go into exam 3 nice and ready. Again, exam 3 will be completely optional. But it will definitely focus on file reading, it will definitely focus on Monte Carlo, it will definitely focus on, it's going to focus on the same stuff as the final exam. I'm just going to have to make basically two versions of the final exam, what it comes down to. That's fine, though. That's fine. I want to make sure that the students, y'all, know how to do what you need to do. Okay? So let's go to, if I go to modules, you'll notice, let's see, do we have a module? Yeah, final project, I just have regex over here. Let's go into regex. Let's go ahead and modify that. Okay, edit. Okay, edit. Let's go ahead and let's see. This assignment will be an in-class exercise. Starting on 11/14. Okay? And and it will have this PDF, and we'll be using a Word text file to do basically what I was doing earlier. And this will be classroom exercises. Awesome. I like this idea a lot. Okay, save. And then I'll have to make its own module for that, but that's fine. Okay, so what kind of questions are we going to be answering ourselves? Okay. Various dictionary. This first one primarily, which is I want you to answer questions about the dictionary file, words.txt. If you're on a Unix system, that means you're on a Mac, you can actually use the dictionary file that's found in your own computer. Dictionary file on Mac. Interestingly enough, right? So you could go to, let's see, it says AI. Somebody can go and navigate to that. So, where is it in C? Yeah, I'm not sure where it would be, but let's see where it says on the forums in 2016. There is /library, so it's in home folder /library. Interesting. On Ubuntu, yep, dictionary file. This is what Pop! OS is based off of, which is what I'm using. It should. Yep, there we go. Let's go and take a look. It's there. CD/user. And it should be in, as it says, it's in /user/share/dict/ NLS. And I've got an American English dictionary right here. Less American English. And there you go. This is the file that by the way, what is the heck is a dictionary file? It is what your computer uses for spell checking. That's what it is. This is the file that my computer uses to say, oh, are these things valid words or not? This is a list of all valid words in my computer's language, as far as it knows. And starting out with the capital ones first, and as you can see, it is quite the big file. Sorry?
Oh yeah, it was all proper analysis.
Yep. So So what we've got, so yeah. So what are we going to be using the dictionary file for? We're going to be looking at different things. Like animals. How many words contain cat or dog in them? You can do that without regular expressions, but we're going to do them with regular expressions to show how do we do such a thing in Python. Okay? Four-letter words are supposedly naughty. How many four-letter words are there? Do more. I'm scared of pyramid schemes and MLMs. How many words contain the hun in them? Do more words end in ing or ion? How many words contain a Q not immediately followed by a U? So we're going to use these kind of things, and as you can see, they become harder and harder to answer without regular expressions. How many words have no vowels? How many words are only vowels? Right? And then we'll be answering these kind of questions as well as writing stuff for kind of writing a strong password detector and how that would work. So these are the kind of exercises we will be working on Thursday. I can see your attention beginning to wane, or really at the edge of waning, so I'm going to trouble you no more with this, but this is what we'll be working on. I know this seems weird to be very enthusiastic about, but I am very enthusiastic about regular expressions. They're very useful, and they saved me a lot of time. They can save you a lot of time as well.